It's recording. Okay, so for number 8, y prime. So first of all, it's an exponential function, right? So the derivative of an exponential function is the function itself times natural log of the base. Of course, if it's e, you could ignore that because natural log e is 1. But it's going to be the exponential function itself, which is x4 plus 1 raised to the third power. Then times natural log of 3, of course, right? But we're not out of the woods yet, right? Because we also have to do the chain rule. So we got to take rid of this, right? And that's going to be, I think it's a double chain because you have to move the 3 to the front, keep the inside intact, drop the exponent by 1, of course, right? And then multiply that inside, right? So there's two insides. The x to the 4 plus 1 cubed, of course, and then as well as the x4 plus 1. That's times 4x cubed, I think. Okay. So you should get 12. So y prime should be 3 raised to that junk cubed times 12x cubed times natural log of 3 times x4 plus 1 squared. I'm not sure what else I would do beyond that. Was the answer key different?
Yeah.
Okay, then give me a sec. Let me think about this one here. Okay, I got you. And here's what they did. Okay, it's stupid. This is really dumb. I know what they did. I'm not gonna look at the answer key until it's my challenge to myself. See if I can figure this out. So 12 is 4 times 3, right? Or 3 times 4. And 3 by itself is 3 to the 1 power, right? So I'm guessing, I don't know. Tell me if I'm wrong. I'm guessing they combined the 3 raised to the x4 plus 1 cubed with the 3 to the 1. Okay, so I'm right. Okay. And it'll be plus 1 on the outside because you're adding those two expressions. And of course, 4x cubed, natural log 3, x4 plus 1 raised to the second power. Don't worry about that if you didn't see that. That's okay. That I think that's really stupid. And I'll be mindful about it when I make the test that you don't have to worry about that kind of stuff. But yeah, that's how you get it. So hopefully that makes sense. So what they're doing is they're re-expressing some of these powers so they can combine powers of the same base. So like 4, they break it down to two, two factors, but it so happens that you have two powers of the same base and want to combine that. So that's what's happening with 8. For 9, yes, about 9 too, Marie. Yeah. Yeah, it's probably the same thing. So it's 3, keeping that intact, right? So that's 3x to the 4 power times natural log of 3. Then derivative cosine is negative sine, so negative sine of 3x4. And times the derivative of that inside, which is 12x cubed. Yeah, they're doing the same thing because 12 is 4 times 3. And they're combining this and this together again, which should have cosine 3x4 plus 1 on the outside. So I'm pretty sure that's what they have. Yep, that's what they did. So it's the same thing. So, yeah. Okay. Other than that, anything else here about this? No? Okay, cool. So here's what I want you guys to do. I have this extra packet to hand out to you guys. I don't think I handed it out yet. I'm calling it extra practice. It's a 12-page document. It has like a lot of worked out problems and some other stuff going on. What I'm going to ask you guys to do, I mean, if you want to read this stuff, cool. Just helps you kind of understand this a little better. They actually do talk about inverses as well, but we're not going to talk about derivative inverses in this class. We'll save that for BC. There's another technique called logarithmic differentiation, where you actually take the logs of both sides and then do derivative afterwards. That's not in the AP curriculum, so I'm not going to talk about it. If we have time, maybe we could talk about this extra stuff down the road. But what I really care about what we've done so far, right? Like, for example, part A, number 1, this is on page 4 of this document. Sorry, page 3. I'm going to give you this document in a moment. For those who have iPads, it's right there. It's called extra practice. But I'm going to have you guys work on number 1, A through P. So it'll be 16 questions. And this will be also considered homework too. Actually, well, that wouldn't be fair because there's no class tomorrow. But anyway, A through P. So yeah, just work on class. That's all you guys are doing today. Just doing more practice with chain rule stuff and maybe some product rule, maybe some quotient rule, perhaps. Yeah, there's a quotient rule for N will involve quotient rule. Don't do QRST because that involves that technique called logarithmic differentiation where you have to take the log of both sides. This is where you have x as a base and x as an exponent. I think someone was asked about that maybe in this class or G period. You'd have to take the log of both sides to do that. Um, we're not going to do that. So you guys are just going to focus on A through P. That's it. And then the answers are on the next page, and they kind of tell you which rule to use, and they show what the answer is. So that's all you guys doing. Let me hand out this packet, and then next week we'll do new stuff on Monday. So, and then we'll wrap up the rest of the notes also on derivative logs and exponentials on Monday. So you guys just working on this right here. And if you're stuck, I can do stuff on the board or come over to you and help you out. Yeah. So you guys doing 16 questions. That's all we're doing, just problem solving setting. With a very light day. And here are the topics. Sounds good. Good.
You know, it's a bird collection. Oh, shit.
Yeah, so this is page 3. Great. Just make sure you guys get a channel. We'll solve.
What was on that specters like that? So is homework or is
I guess. Sure, council work.
Okay.
Yeah. Yeah, that'd be a good idea. I was doing some piece of paper. If you squeeze it, I don't think you can squeeze it in though. I doubt that.
Siri, can we look out there?
Sure, yeah, 100%.
Okay.
I thought so. Ooh. So it's. I guess.
Sometimes we want to lost it. I think it's just.
No,
So, yeah, first.
This is what's there.
It's natural.
Oh. Yes. What's up?
Where it has part of it,
Correct. Right. Yeah, and like I think the answer is yeah. Well, I don't know. Yeah. Yeah. I don't think it's everything.
Did I multiply everything?
Hold on a sec.
I multiplied everything.
No, I think you're fine. I think you're fine with that. Yeah, you're fine. Yeah, you're good. You're done. Good.
Yeah.
What?
No problem.
Yeah.
Oh, I guess you could do that. We didn't like that. Would take the, yeah, that's fine. I just didn't take any, so about 3x out of it. So I five.
Oh.
What's all the you should say? Or push the, no, three, oh, God, we're talking about this. Yeah. Oh, what's this? What's the issue? The issue. Oh, I saw the button. Using. Oh, hi. That's. You. Oh, so hard to be used. Each thing is like you.
You should consider the function. It's like four to the power of 4x. 4x or 4x, 4 to the power of 4x squared. So 4x squared is also. Yeah. Oh, yeah. I will. Like.
Probably would.
I don't think so. Oh. Oh, okay. That'd be.
Doesn't seem that, oh, it does, yeah, I see how the. What?
Where's the power of 6?
Well, I don't guess, nothing will consider that. Or what? Three? Receive you get. Oh, I didn't supply it.
No.
You don't have to say they're required, you know.
Oh, they can put X in there. Oh,
This one. You know.
right.
Probably not, yeah. You know, what? More you want to buy. Yeah. What should we have? Six? Yeah. Yeah, Pro sorry. Well, I'm gonna consider it, like, oh, does that actually use powerful? Okay. This is like, yeah, no, actually, one. Would be. What do you think that's the good time? Nothing. I think about that. No, that's a motion. Control number. Wait. It's just you don't, you pass it out of 3x. Well, 5 out of 3x.